Hello, everyone. Welcome back. Today we're going to be discuss the Apache Kafka, a complete in-depth concept and guides. This will cover the Kafka architecture, storage, internally producer, consumer mechanism, basically, and delivery guarantees, Kafka connections, streaming, then schema management, operation configuration, everything needed to build a solid model for of the how the Kafka work end to end. So we'll going to cover all of these points in this series. First of the point. What Kafka actually is, core architecture, producer, consumer, storage internally, like metadata management, and like we have some care of the zookeepers, some deliveries, synaptics, Kafka connection, Kafka streaming, KSQLDB, like schema management, key configuration, keynotes, some common failure scenarios, and some tips and tricks how to handle the failures, when to use Kafka and when to not use the Kafka. All of these things will going to cover in this video. And talking about the video will be the little bit long, but we're going to be cover all of these points whichever I mentioned. Like we have the 14 point, we will going to be cover all of these things. Okay, so let's start with the very first. What is the actual Kafka? And now, if interviewer asks you why, how we're going to be, tell them the Kafka is a distributed event streaming platform. At the one core, it distributed append only the commit log that lets producer publish the records and consumer read them durably in order per session partition, and at the high throughput original build at the LinkedIn. It's widely used for the messaging, pub sub mechanism, log aggregation, streaming processing, event sourcing, matrix activities, tracking, data integration between the streaming like pipeline, ETL, and all of these things is done via the Kafka. So as all of these thing is mentioned here, so you can see the uses of the Kafka is messaging, where you get the notification on mobile system, logging aggregation. We have the aggregation logging system where we do the Kafka over there. So let's see some changes happen in the real DB. We wanted to update that in the aggregation, so we can trigger the public event, so that aggregation can done separately. And one more thing, like streaming platform, streaming process there, like let's see the video, YouTube video, they wanted to stream that, so that time also it help us event sourcing, like lot of notification sending, matrix activity tracking. Let's see, in your database, your real product, you are getting some errors or some unwanted matrix or unwanted cause or unwanted error. So that time you have to send the event, send the matrix activity, track that, so that we use Kafka for that. Okay. When does not use to the Kafka. Kafka is not traditional use of the queue like RabbitMQ. Messaging are not deleted from the consumption. It's log the consumers read from the own piece. Multiple consumer can independently read same data at the different offset. Let's say when you wanted to do some processing like data. And queuing, basically any message you wanted to queue, that time don't use the Kafka. We have the rabbit MQ, we also have the Redis as a queue, then we also the messaging queue, a lot of thing we do have, so that we will going to be used or for that this part. So for the only purpose of like sending the messages, triggering the event, and subscribing, that we use the Kafka. Okay, so let's start the second very important part is the architecture. How does it work? So you can see the very important thing. Producer, we have the producer, like producer, and then Kafka cluster, like which called the broker and consumer. So we use some zookeeper and our k of metadata for the Kafka broker. Basically, it create the different broker like 1, 2, 3, 4 do not to fail the message to reach the consumer, so that we use the Kafka cluster, and that called the broker. So there are the multiple broker like producer is something we trigger the event, and Kafka broker cluster is multiple, like 1 2 3 4, with doing the same work but in different pipelines. So that's the cluster. And as earlier mentioned, a single Kafka server, a cluster is a group of brokers. Each broker host same partition, handle the read write request from them. So let's see topic, let's see one topic. We have the name, a name stream of record thing of the category or feed name. Example, user sign up, order events. So topic are logically partition up by are physically. So some of one of the most important is partition. You got the two words in broker and topic as well. So we'll discuss the part, what does partition mean. Okay, so partition is the each topic is split into the partition like orders, mutable sequence of the orders, records. This is the unit of the this is the unit of. So parallelism, each partition can consume independently, ordering guarantee only within the partition, not across the whole topic. Storage, each partition have the file on the disk. So partition is the, as name suggests, we are partitioning the thing. Let's see, we have the we can trigger the event parallelly across the different platform. But let's see, we only send event or partition part to some ordered. Okay, so that's the use of the partition. We partition based on the event. Let's see, some user is sign up, so we only partition one cluster for that. Okay, so offset, each record within the partition get a sequential ID, like we in the partition we also have the different event and different offsets. So it get the create the one sequential ID and offset are the pre-partition, not globally to the topic. Consumer track offset to know what they have read. And let's talk about the replica across the broker for the tolerance. Like replicas, you as you know about the system architecture, we are the very popular concept with replication of the server. Basically we have the server, so we create the replication. So same concept we use over here, leader, which handle the write for the that particular partition. Some also we have the followers, like for fascinately replicas that log into the followers. So we have the one readers, leaders which read and writes the thing. But we have some replicas which sync automatically and get logged into others replicas as well. A replica factor 3 is common in the production, like one master leader and two tolerance broker if failures. Okay, so producer is the public the require to the topic key concept partitioning strategy. If the key is provided, Kafka hash into the decode decide the partition, like same key, same partition, and guaranteed order for the that key. If no key, Kafka use the round robin strictly partition for the load balancing. At slow load balancing like this, acknowledgement like control durability guarantees, like ask 0, fire and forget to no guarantee. Leader, as 1 leader write to the logs, does not wait the replicas, same the loss. As all, so it will wait for all. Leader wait for the all replicas to knowledge strongly durability. As one, as you suggest the numbers, it not guarantee you will going to be push that notification properly. 0 means at least one replicas get that thing. And ac- acknowledge all means everyone should have to update an acknowledgement to us, then only we will going to be log that. Okay, so one more in idempotent producers, which is very important for the batch processing and consumption. So PID, which called the which concept provide the duplicate right on the read write by the assigning the producer ID, which called the PID in the concept. So and sequence number per partition enable exactly one the semantics within a partition. So PID is the most important concept, which called the ID for the each partition producer. It's important for the event. Batching and compression producer producer batch record like batch size linear ms to important throughput and can compress batch like gif files snigif lgs gif. Okay, so transactions producer can write to the multiple partition topic automatically using the traditional id critical for the exactly once produce the pipeline using the heavy with the Kafka streaming as well. So fourth part is the consumer, which is very important as well. Consumers mean, let's see, in real based application notification system for your mobile application. You in that case your mobile user is the consumer. Okay, so we will talk about the consumer group. So consumers subscribe the topic as the part of the consumer group. Kafka distribute the partition among the group member. Each partition is consumed exactly one consumers within a group at a time. This is how the Kafka achieve parallel consumption while the serving per partition order. So what does consumer mean? Consumer have the each group. Let's see, one group for the order, one group for the menu, one group for the sign up. So each group have the consumer different consumer. Based on the consumer, we consume that particular partition. So more consumer than partition, some consumer set ideal. So fewer consumer than partition, some consumer handle multiple partition as well. So offset management, let's see, consumer commit the offset usually to an internal Kafka topic like consumer offset to track and progress is like auto commit periodic. It's rig the reprocess or loss on the crash. Manual commit explicitly control common in the production exactly once the reach and sentiment. Rebalancing, when the consumer joins leave a group partition change Kafka reassign partition among the group, like it called the rebalancing. So Kafka automatically rebalance the load based on the strategy. Eager rebalancing, corporate straight rebalancing, both two algorithm is more modern, and but mostly most of the case we use these cooperative strictly rebalancing, which is modern and default in the Kafka. Consumer group coordination, a design broker manage the group members heartbeat and trigger the rebalancing. So it's handled and internally. Okay, so next point is a storage and internals. Important thing is a log. Okay, so the log, each partition is store the segment file like log index time index. Kafka relies on the sequential disk output input output much faster than the random input output. Each even the snippet disk OS page caches like Kafka logs internally. Kafka avoid the manage it on caches read write go through the page caching, and it's use the zero copy like send file to transfer data from the disk to network socket without copying into the other user space. Basically hug a reuse for the Kafka. Log retention to cleaning the policy delete discard older than the retention ms or beyond the retention bytes. compact, keep only the latest record for log. Like we have the multiple log, we based on the time and generation it's delayed log. So use the change log topic in the Kafka streaming, maintaining the current state topic log segment. Active segment is currently returned to the plus older close segment. Older segment become the eligible for the delete and compact based on the retention policy. And sixth topic is the metadata management, which is important. Zookeeper and Kraft is the two way to do that. Historical Kafka depend on the zookeeper for the broker. Once the broker register leader elected to that, it is similar to the internally it use the our um, Dixit algorithm to find the nearest location. So historical Kafka depend on the zookeeper for the broker registration, leader election, cluster metadata, ACL configuration as well. Okay, so Kraft is the mode of reviewing zookeeper dependency. Kafka manage its own by metadata using the array of base consumption control nodes. This simply operate and improve the scale since the Kafka is 3x product ready and default newer version like keepers mode is the phased out removed in the Kafka 04. Most important topic is delivery segments. Okay, so segments, and we'll discuss the description. At most one message may lost when the delivers commit offset. So at least once he will try, at least once message never lost or may never delete. So in this case, how does it works? Actually, we have the system mechanism. Once the event or message is delivered, it check whether it is deliver or not. If not delivers, it retry in the at least once. But in most ones, it only send that message. Once it is sent, he will not do any other thing. Means that we can lose some messages as well, but at least once we are not going to lose any of the message or any of the commit, because we are exponentially sending that particular message repeatedly. But at certain period of time, we're going to store that message in xyz mechanism so that we can handle that manually. How we do like this or in this and explain explicitly once, no loss, no duplication, achieve defaulted transparency and traditional consumer id basically. And our 8 point is a Kafka connection. This is the based on the different project which you service, which technology, which um, programming language you are using. Based on that we connect. But more all of the framework, we have the libraries for to connect the Kafka, a framework to integrate the Kafka with external system without writing the custom code. So we have the source connector which called the CDC, using the divism from the file from the source connector, pull data into the Kafka from the database via CDC. Then we also have the sync connector, push data out of the Kafka. Is a example Elasticsearch, S3 bucket, data warehouse. We also run the standalone distributed mode like distributed our distributed server. Use the Kafka itself, store the connector configuration, offset, and status of the fault tolerance as well. Okay, so next topic is the Kafka streaming, which is the most important for the streaming platform, which have the lot of records and lots of data. That time we use the Kafka streaming, a client library for the building streaming process application directly on the top of the Kafka. No separate cluster needed, unlikely flash link or sparks basically. K stream record stream each record into independent event. K table catalog change the abstract representation latest state per key. Back to the compact topic, like okay, so K table is called. So we have the global table, fully replicas table every instant, good for the all reference data joins. Streaming the table's quality, a stream can be as table change log and vice versa. State store local user rock db and state for the aggregation join block by the catalog changing topic for the wow tolerance. Windowing, we have the windowing mechanism, tumbling, hopping, sliding season window for the best aggregation as well. We also have the one mechanism which called explicitly once processing process support via the processing dot the guarantee exactly once the topic which we have in the system. Then we also have the KSQL DB, which mostly not going to use, but in Java, particularly in Java, we sometimes use the SQL likely layer, the top of the Kafka streaming query and transforming stream table into the SQL syntax instead of the Java skills code. So we use ksql db over there. And last one is the schema management. This is the important, since the Kafka store the raw wide scheme evaluation matters. So schema registration store the Avro product JSON schema, enforcing capability rule, backward forward full capability to the producer and consumer schema version. Avoid the classic problem producer and consumer breaking into the format changes. And 12th point is a key configuration keynote worth. Keynote key configuration replica factors. We the fault tolerance levels, then mini dot in sync replicas, minimum ISR count required for the us all. We should be ask for the all replicas. Unclear leader election dot enable. So each leader it's enable basically the mechanism of the leader and followers mechanism. Retention ms, it used for the log purpose, how we have to which mechanism we have to keep for the enable the log, how much time we have to keep the data in log data in the system. Num partition, we have to create the new different partition. So we count the new topic using the num of partition. Maximum boolean records, we have the size for full the records. Season timeout, we can give the season timeout based on this configuration in the Kafka. This is a too simple to use. Last, we have the common failure scenario and guarantees the failures, how the failures happen. Broker failures, we have the leader election ISR, which means the synchro replicas. It made the producer right within the as all failure rather than risks silent losses. We also have the consume crash mid process, like dependency commit strategy message get process produce or at lost once or lost most once. Then we also have the network partition. Kafka user ISR control the quorum to avoid the split brain replicas that falls for the behind get removed from the ISR. Okay, so next, when used to Kafka or not to use the Kafka, this is most important. Good fit, high throughput event pipeline, discoupling the microservices, event sourcing, real time data analytics, log aggregation, CDN pipeline or CDC pipeline. We use Kafka for that. Also, the event very in pub sub mechanism, you must have to use the Kafka. and proof fit for simple task you need, like for messaging quick attack retrace in a synonym mix with the complex routing. Use the rabbit mqs or sqs, may be simpler, very low latency request the response. The Kafka is optimized through output, not sub million second latency. Small scale app where you operational overhead is just justified. That's what the thing we wanted to discuss, and thank you for all.